Hi everyone, my name is Hailey and I'm a 10th grade student at Acellus Academy. My science fair project this year was a tooth decay with regards to eggshells lab. Eggshells are made out of chemicals that are similar to the chemicals that make up our tooth enamel. Eggs are made up of calcium carbonate, specifically in the eggshell, and tooth enamel is made up of calcium phosphate. Held together by ionic bonds, depending on the pH of the solution they are in, both can be dissolved by the way of demineralization. In other words, certain pHs can weaken eggshells and tooth enamel. pH can lead to demineralization. Cola, Pepsi, cranberry juice, and coffee have a lot of H+ atoms, so they are very acidic. You can also reverse this process by remineralization. Put fluoride toothpaste on a toothbrush, then wipe the brown layer on the eggs. This fluoride ions remineralize and the eggs become whiter. High acidic concentration serves the ionic bond that holds calcium phosphate, tooth enamel, and calcium carbonate eggshells together. Materials used in the lab: 6 plastic cups, 6 eggs, cranberry juice, cola, milk, water, coffee, vinegar, and then we use a Sharpie, a spoon, plate, toothbrush, and toothpaste with fluoride. Procedure: hard boil 6 white eggs. 2. Label 6 cups with the liquids you are using. 3. Put the liquids in each labeled cup about 1/2 to 3/4 full. 4. Add 1 hard-boiled egg in each container once cooled, and let the eggs sit in the solution for 4 days. 5. After 4 days, take the eggs out of the liquids and place on a plate. 6. Observe what happened to the eggs. Observe if they changed color or had any other physical changes. I'm going to be placing a plain white hard-boiled egg into each of the following solutions. Our first egg goes into water. Our next egg goes into cranberry juice. This egg will be going into vinegar. This egg will be going into cola. This egg will be going into milk. And our final egg will be going into coffee. I'll be back to check the eggs in 4 days. It is 4 days later and I want to see what's going on with our eggshells. So here's the one we had in water. Overall, our shell has pretty much stayed exactly the same. There's been no color change and no change in the shell. Now let's go to our egg that was in milk. The egg stayed pretty much exactly the same. There's no change in the shell and there's no change in the color either. Now we move on to our egg in cola. We had a nice color change here. Our shell turned to a darker brown, but overall the shell itself didn't really change. As for our egg in coffee, we have a nice light brown here, though there was no change in the shell. As for our egg in cranberry juice, we have a nice deep brownish black, but then we also have a change in the shell as well. We can see all the bubbles have changed, really, the entire shell. It sort of dissolved a little bit. And then for our final egg in vinegar, we basically lost our entire shell. The shell dissolved itself, and it's sort of like a bouncy ball texture, but basically the color stayed exactly the same. So there you have it. So we have our coffee egg right here, and as you can see, the eggshell went through demineralization, and through the fluoride in toothpaste, we're going to see if our eggshell remineralizes, as our teeth are made up of similar material as our eggshells. So I'm going to put some toothpaste on our egg. And then let's see what happens. As we can see, that there's sort of a color change back to its original color. We're definitely getting some of the brown off. So yes, you can see that definitely we can get the eggshell back to remineralization. Discussion. Cola contains phosphoric acid. Vinegar contains acetic acid. They can deteriorate eggshells. Water is not acidic, so eggshells do not break it down. Milk has lactic acid, but it's less concentrated and it may not see deterioration. Eggshells contain calcium carbonate, which reacts with acid in vinegar called acetic acid, breaks up then calcium and carbonate, dissolving the shell. And while calcium floats away, the carbonate reacts with the acetic acid that creates CO2. You may see the bubbles on or around the eggs.